Welcome back to Advantage Masterminds. Before I start, let me thank you all for subscribing to the channel. It is because of your constant love and support that we have reached so far. This time we are starting with the chapter of physics, that is light. For the ease of understanding the concepts of this chapter, we have divided this chapter into 3 parts and will be adding a few more later. They say in order for the light to shine bright and also to conduct the experiments well, there should be complete darkness. And who can do it better than Elton Fernandez? He has been doing numerous experiments to understand this chapter better. He has his own channel as well. The link to his channel will be provided in the description box below. Do check it out.
Hi! It's so nice to see all of these colorful objects. This bottle is yellow, this pencil box is blue, my shirt is black, and so on. There are so many colorful things around us, and even if we keep them all together, we're able to see them with their individual colors. But what is this? Why am I not able to see anything now? Can you help me see things in the dark? Hello? I am talking to you. Can you see me? Oh, I can see everything again. Isn't it beautiful to be able to see everything? There are 2 important things which make this possible. They are light and sight. Without the presence of these 2 things, our world will be one dark state. Let us study about light in greater detail. When we think of light, we always think that light is made up of 7 colors. But it is not so. Light is a form of energy which consists of visible and invisible light. It is only the visible part of light which is split into 7 colors. When the visible light falls on our eyes, it produces the sensation of vision and color. So, what is the main source of light? It is the sun. Sun not only gives us light, but it is also the source of life. Without sunlight, there will have been no plants. And if there were no plants, then of course, none of us either. There are other sources of light as well. The 2 sources of light are natural and artificial. The natural sources of light are sun, the stars, lightning, fireflies, jellyfish, etc. The artificial sources of light are candle, bulb, tube light, torch, etc. We can also categorize the sources of light as luminous and non-luminous objects. Luminous objects are those which emit light of their own. For example, sun, stars, candle, torch, lamp, fireflies, etc. Whereas non-luminous objects are those which do not emit light of their own, but they become visible or they shine when the light from the luminous body falls on them. For example, the moon, planets, table, chair, etc. For example, this table, this book, paper, myself, this glass are all non-luminous objects, whereas this tube light and this torch are luminous objects. While I was showing non-luminous objects, you must have noticed that the book and the table formed a shadow. But this paper creates a very light shadow because a small quantity of light can pass through it. But when you look at the glass, we see that the light can pass through it completely. Objects through which light cannot pass at all are called opaque objects. Table and book are some of the examples. Objects through which light can pass partially are called translucent objects. For example, butter paper, ground glass, etc. Objects through which light can pass completely are called transparent objects. Glass and air are some of the examples. There are some facts of light which we should remember. Light travels in a straight line in a form of a ray. Light does not require a medium to propagate. It can travel with or without a medium. Light travels fast. It travels at a speed of 3 into 10 to the power 8 meters per second in air or vacuum. Do you know its speed in water? If you know the answer, then write to us in the comments below or watch our series of light to know the answer. Have you ever noticed a ray of light playing hide and seek between the trees, or a beam of light trying to enter through a tiny hole? Well, what does it prove? Even though we know that light travels in a straight line, let us perform one simple experiment which can prove that light travels in a straight line. So let us start this DIY experiment. For this activity we need 3 pieces of chart paper, some clay, laser pointer, white screen or wall, pencil and a pair of scissors. Take all the 3 chart papers and put them together like this. And then take the scissors and poke a small hole in the center of all 3 together. Then separate them and make the holes round and more well defined. Then put some clay under the chart paper and check whether it stands erect or not. This is done. Place them one behind another at a distance in a straight line. Now flash the laser beam from one end of the cardboard piece. We observe that the laser beam travels to the 3 holes of the cardboard pieces and falls on the white screen. But what happens when we shift one of the cardboard slightly? Yes, the laser beam does not fall on the white screen. Now again, when we align the chart paper with the 2 others, we are able to see that the light falls on the white screen again. This experiment shows that the light travels in a straight line. But if it had taken a wavy or curved path, then we could have seen the laser beam even on displacing one of the chart papers. This movement of light particles along a straight path is known as rectilinear propagation of light. Rectilinear propagation of light has many applications, but the most important ones are pinhole camera, formation of shadows, formation of eclipses. Let me show you how to make your own DIY pinhole camera. It is so much fun to make your own scientific toys. Maybe one day I'll also have my own science lab. It will be so much fun. But now let me show you how to make the pinhole camera first. Materials required are a lighted candle, a shoe box or any other smaller empty box, a thick needle, tracing paper and glue. First take the box and poke a tiny hole in the center of one of the sides like this. Then cut out the opposite side of the box and stick a piece of tracing paper to it. So on one end you have the hole and on the opposite end you have the tracing sheet. Now take the lighted candle and let it face the hole. We see that an inverted image of the candle is formed on the tracing paper. This is known as its image. It is not only inverted but it is also smaller in size. But the size of the image varies. It depends on the distance of the screen and the hole, and also on the distance between the screen and the object. Do you know what will happen to the image if we increase the distance between the hole and the screen? If you know the answer, then put it in the comments below or watch our videos till the end to find out. Now, if we replace this pinhole camera with this book and switch off the light, but the candle is still lit, we see that a dark patch is formed. This dark patch is known as shadow. The shadow is similar to the shape of the object, but this is also based on the rectilinear propagation of light. The solar and lunar eclipses are also based on the same principle. When the moon comes in between the sun and the earth, the moon casts a shadow on the earth. This is known as solar eclipse. And when the earth casts a shadow on the moon, then it is called lunar eclipse. The shadows which are completely dark are called umbra, and the shadows which have some brightness and are not completely dark are called penumbra. The penumbra always surrounds the umbra. Do you know why we do not see the shadow of the birds flying high up in the sky? If you know the answer, then write in the comments below and subscribe to the channel. And if you are the lucky winner, then you will hear the shout out from us. So what are you waiting for? Hurry up and like, share and subscribe to our channel. Do not forget to write the correct answer. Keep watching and I'll be back soon.